The morning of February 25th, 1945, dawned cold and gray over the waters off Yokosuka. Lieutenant Junior Grade aboard the USS Bennington watched his Corsair's hydraulic pressure drop to zero, the gauges spinning down as flak damage from the coastal batteries took its toll. He had perhaps 3 minutes before the engine seized completely. The inverted gull wings of his F4U caught the wind as he struggled to maintain altitude. But the Pacific was rising fast to meet him. When the aircraft hit the water 2 miles offshore, it broke apart, the massive Pratt and Whitney R2800 engine dragging the nose down as seawater poured into the cockpit. He scrambled out, watched his aircraft sink beneath the waves, and began swimming toward what he hoped was friendly territory. He was wrong. By nightfall, the Corsair was no longer at the bottom of Sagami Bay. Japanese naval recovery teams, working with remarkable efficiency despite the deteriorating war situation, had located the wreckage in relatively shallow water. Within days, the aircraft, Bureau number 82,410, was being transported under cover of darkness to the Kasumigaura Naval Air Technical Arsenal, approximately 60 miles northeast of Tokyo. It would not be the last Corsair to fall into Japanese hands that month. On the same day, another F4U from the USS Essex made an emergency landing in a field near Tsuchura City in Ibaraki Prefecture. The pilot was captured. The aircraft, remarkably intact, became an intelligence prize of incalculable value. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. For the engineers at Kasumigaura, the arrival of not one but 2 American Corsairs represented both an opportunity and a bitter confirmation. By early 1945, Japan's situation in the air war had become catastrophic. The vaunted Zero fighters that had dominated the skies in 1941 and 1942 were being systematically destroyed by newer American aircraft that outclassed them in nearly every measurable category. Production facilities were being bombed relentlessly. Fuel was scarce. Experienced pilots were dying faster than they could be replaced. And now, sitting in their hangar, was tangible proof of just how far American aviation technology had surpassed their own. The Kasumigaura Naval Air Technical Arsenal was not some backwater facility. It housed some of Japan's finest aeronautical engineers and test pilots, men who had designed and evaluated fighters since the 1930s. They had studied captured American aircraft before, P-40 Warhawks, P-51 Mustangs, even a B-17 Flying Fortress that had been painstakingly reconstructed and flown. But the Corsair was different. This was the aircraft that Marine and Navy pilots had been using to methodically destroy Japanese air power across the Pacific. This was the fighter that Japanese pilots reported could not be caught in a dive, could not be outrun in level flight, and seemed to absorb punishment that would shred a Zero into flaming debris. Navy Lieutenant Toyota Takago, one of the designers working in the foreign technology program, later recalled the moment they first examined the captured Corsair up close. The sheer size of it was startling. Standing beside a Zero, the American fighter looked like it belonged to a different species of aircraft entirely. The Corsair stood 4.5 meters tall at its vertical stabilizer. Its wingspan stretched 12.5 meters. But it was the engine that commanded attention. The massive Pratt and Whitney R2800 Double Wasp, an 18-cylinder radial power plant that displaced 2,800 cubic inches and generated over 2,000 horsepower. For context, the Nakajima Sakae engine that powered the Zero produced 1,130 horsepower. The Americans had built a fighter around an engine that was nearly twice as powerful. The engineering team began their examination methodically, documenting everything. They measured the thickness of the armor plate behind the pilot's seat, nearly 40 millimeters of hardened steel. They examined the self-sealing fuel tanks, technology that Japan had struggled to implement effectively in its own aircraft. They studied the 6 Browning M2 50 caliber machine guns, 3 mounted in each wing, each capable of firing 800 rounds per minute. The ammunition capacity alone was staggering. 400 rounds per gun, 2,400 rounds total. A Zero carried 60 rounds for each of its 20-millimeter cannons. But it was when they began stripping down the wings that the engineers encountered something they hadn't expected. Toyota later recounted their surprise. Portions of the wing were covered with fabric, on an aircraft that represented the cutting edge of American military aviation, on a fighter that had terrorized Japanese pilots across thousands of miles of Pacific theater. They had assumed that American industrial might would manifest in purely metal construction throughout. Instead, they found that the Corsair's wings behind the main spar used fabric covering over metal framework, a technique that was lighter and, in some ways, more practical than all metal construction. This discovery was both puzzling and revealing. It suggested that American engineers understood something fundamental about aircraft design, that the newest technology wasn't always the best technology, that proven techniques still had value, and that practical functionality mattered more than impressive-sounding specifications. The Japanese engineers noted this in their reports. They also noted the construction quality. The welds were clean. The control cables were precisely tensioned. The hydraulic systems, though damaged, showed sophisticated engineering. Even in the WWII details, the way the cockpit was laid out, the clarity of the instruments, the robustness of the landing gear, the Corsair reflected a level of manufacturing precision and quality control that Japan's overstretched wartime industry could no longer match. The team worked to make at least one of the 2 captured Corsairs airworthy. They cannibalized parts from the more damaged aircraft, using components to repair the one that had made the emergency landing near Tsuchura. They patched holes in the fuselage with aluminum sheet metal. They covered damaged sections of wing with fabric, using techniques they understood from their own aircraft production. They tested the hydraulic systems, cleaned the fuel lines, and examined every control surface for damage. It took weeks of careful work, conducted even as American B-29 bombers struck targets across the Japanese mainland with increasing frequency. The question that consumed the engineering team was simple. How good was this aircraft really? They had the specifications on paper now. They knew its dimensions, its weight, its armament, but numbers on a page couldn't tell them what they needed to know. They needed to understand how it flew. They needed to know what it felt like in the hands of a pilot. They needed to discover if there was any weakness, any vulnerability, any tactical approach that could help Japanese pilots survive encounters with this machine. By late March of 1945, they had one of the Corsairs in flyable condition. The Pratt and Whitney engine started with a thunderous roar that shook the hangar. The massive 3-bladed propeller, 4 meters in diameter, carved through the air with authority. The aircraft sat on the tarmac at Kasumigora like a predator, its distinctive inverted gull wings giving it an aggressive stance even when motionless. A test pilot would soon climb into that cockpit and take it into the air over Japanese territory. What he would discover in that brief flight would confirm what many Japanese pilots had already learned through bitter experience in combat. The Corsair's arrival at Kasumigora came at a moment when Japan's naval air forces were in their final death spiral. The First Air Fleet, which had once projected Japanese power across the Pacific, was being systematically annihilated. Experienced pilots who had trained for years before the war were nearly all dead. Their replacements received perhaps a few dozen hours of flight training before being sent into combat against American pilots who had hundreds of hours in type and who flew aircraft that were superior in almost every way. The kamikaze corps, born of desperation, was consuming pilots and aircraft at an unsustainable rate. And now the engineers at Kasumigura were preparing to fly an aircraft that represented everything Japan could no longer produce: overwhelming power, robust construction, and the industrial capacity to build them by the thousands. The cultural context mattered. 2. Japanese military aviation had been built on certain principles: lightness, maneuverability, range, offensive capability. The Zero had embodied these principles perfectly when it first appeared. It could outmaneuver anything in the sky. It had range that seemed impossible for a carrier-based fighter. It carried heavy armament, but it achieved these capabilities through radical weight reduction. There was no armor to protect the pilot. The fuel tanks were not self-sealing. The airframe could not withstand heavy punishment. These were conscious design choices, reflecting a philosophy that emphasized attack over defense, that assumed Japanese pilots would always seize the initiative, always strike first, always maintain air superiority. The Corsair represented a fundamentally different philosophy. It was built for a long war. It was built to be survivable. It was built to be maintained in the field by mechanics who didn't need to be engineering specialists. It was built to protect its pilot so he could fly mission after mission, accumulating experience and skill. And it was built in quantities that Japan simply could not match. By early 1945, American factories were producing Corsairs at a rate of several hundred per month. Japan's entire aviation industry was producing fewer fighters than that across all types, and many of those never made it to operational units due to fuel shortages, inadequate training of pilots, or destruction in American air raids. The test pilot assigned to evaluate the captured Corsair understood all of this. He knew the war was lost. He knew that any intelligence gathered from this flight would likely never make a difference in combat outcomes. But he also knew his duty. If there was any weakness in this aircraft, any vulnerability that could help the pilot still fighting and dying over Okinawa, over the home islands, over what remained of the Japanese Empire, then he needed to find it. He climbed into the cockpit, settled into the seat, and began his pre-flight checks. The American instruments were labeled in English, but the basic layout was familiar enough. Throttle, mixture, propeller pitch, oil pressure, fuel pressure, cylinder head temperature. The control stick was different from a Zero's, heavier, more robust. The rudder pedals required more force. Everything about the aircraft felt substantial, solid, over-engineered compared to the lightweight fighters he was accustomed to. He advanced the throttle and felt the Pratt & Whitney engine respond with a surge of power that pushed him back in his seat. The acceleration was immediate and brutal. This was what 2,000 horsepower felt like. This was what American pilots experienced every time they took off. The Corsair rolled down the runway, gaining speed with shocking rapidity. At 120 kilometers per hour, he pulled back on the stick, and the fighter leaped into the air. In that moment, everything changed. The Corsair climbed like nothing he had ever flown. The rate of climb was extraordinary, over 1,300 meters per minute at sea level. In a Zero, you coaxed the aircraft into the air, managing every bit of power carefully. In the Corsair, you commanded it. He banked left, feeling the controls respond. Heavy, yes, but precise. He rolled right, testing the rate of roll, fast. Faster than he'd expected from such a large aircraft. He climbed to 3,000 meters and leveled off, then advanced the throttle to maximum power. The Corsair accelerated, the airspeed indicator climbing past 500 kilometers per hour, past 600, past 650. At 670 kilometers per hour, he was approaching the aircraft's maximum speed in level flight. and the Corsair was still accelerating smoothly with no buffeting, no vibration, just pure speed. He dove, pushing the aircraft into a steep descent, and watched the airspeed climb past 700 kilometers per hour. The control surfaces remained responsive. The airframe remained stable. In a zero, diving at this speed would risk structural failure. The wings might literally tear off. Here, in the Corsair, everything remained solid and controlled. He pulled out of the dive, feeling the G-forces press him into the seat, feeling the robust airframe absorb stresses that would have destroyed a lighter fighter. He climbed again, bleeding off speed, then attempted a series of aerobatic maneuvers, loops, barrel rolls, Immelman turns. The Corsair was not as agile as a Zero in slow-speed maneuvering. In a turning fight below 300 kilometers per hour, a skilled Zero pilot could outturn the American fighter, could maintain a tighter turning radius, could bring guns to bear first. But the test pilot also understood something that many Japanese pilots had learned too late in combat. The Corsair didn't have to turn with you. It could dive away at speeds you couldn't match. It could climb away at rates you couldn't follow. It could extend out of range, reset the engagement on its own terms, and come back at you with an energy advantage you couldn't counter. He spent perhaps 20 to 30 minutes in the air, testing every aspect of the aircraft's performance he could safely evaluate. He tested stall characteristics, docile and predictable compared to some Japanese fighters. He tested landing configuration. The massive propeller required a careful approach angle to avoid scraping the runway, but the aircraft's power margin meant you could add throttle and go around easily if the approach wasn't perfect. He tested the gun sight, the visibility from the cockpit. Better forward visibility than he'd expected given the long nose, though the cockpit position far back on the fuselage created blind spots during landing. When he finally brought the Corsair back to Kasumigara and shut down the engine, the silence was profound. The engineering team gathered around him as he climbed out. Of the cockpit, they wanted to know everything. What did it fly like? How fast was it really? How did it handle? Were there any weaknesses, any vulnerabilities, any tactical approaches that might give Japanese pilots an advantage? The test pilot's report, though not preserved in complete detail in surviving records, would have confirmed what was already known from combat experience and what the specifications suggested. The Corsair was faster than anything Japan had in operational service. It could outclimb Japanese fighters across the entire altitude range. It could outdive them by a significant margin. It was rugged enough to absorb battle damage that would destroy a Zero. It had firepower that could shred a Japanese fighter in a single burst. Its only meaningful weakness was reduced maneuverability at low speeds. And even that weakness didn't matter because the Corsair could simply refuse to fight at low speeds. The implications of the test flight were devastating in their clarity. The engineers at Kasumigara compiled their findings into detailed technical reports that circulated among what remained of Japan's Naval Air Command structure. These reports, written in the dry language of technical analysis, contained a simple and unavoidable truth. The F4U Corsair represented a level of aerial combat capability that Japan could no longer match, let alone exceed. More troubling still, the Corsair wasn't even the newest American fighter in service. The F4U-4 variant, with its more powerful engine producing 2,450 horsepower with water injection, was already reaching operational units. And beyond that, the Americans were developing jet-powered aircraft that would render even the Corsair obsolete. But the captured Corsair revealed more than just performance specifications. It told a story about industrial capacity, about manufacturing philosophy, about the vast gulf that had opened between American and Japanese war-making ability. Every component of the Corsair reflected a production system that could afford to over-engineer, to build in redundancy, to prioritize pilot survival and aircraft longevity over raw numbers. The hydraulic systems used high-quality seals and precision-machined components. The electrical wiring was neatly organized with clear labeling. The engine accessories, the magnetos, the carburetor, the fuel pumps, were built to tolerances that Japanese manufacturers could no longer consistently achieve. One of the most telling details was the propeller itself. The Hamilton Standard hydromatic propeller was a marvel of engineering, a constant speed, variable pitch system that automatically adjusted blade angle to maintain optimal engine RPM across different flight regimes. Japanese engineers had attempted to develop similar systems, but quality control issues and material shortages meant that most Japanese fighters still used simpler, less efficient propeller designs. The Corsair's propeller alone that single component represented a level of manufacturing sophistication that required machine tools, precision measurement instruments, and quality control systems that Japan's bombed-out factories could no longer sustain. The fuel system revealed another disparity. The Corsair carried 934 liters of fuel in self-sealing tanks, rubber bladders that would automatically seal around bullet holes, preventing catastrophic fuel leaks and fires. Japanese engineers had studied self-sealing tank technology for years, had even implemented it in some aircraft, but the rubber compounds required were in desperately short supply. Many late-war Japanese fighters still used unprotected fuel tanks, meaning a single incendiary round could turn the aircraft into a fireball. The American pilot who had ditched his Corsair off Yokosuka had been protected by armor plate, a armored windscreen, and self-sealing tanks. If he'd been flying a Zero and taken the same flak damage, he would likely have burned to death before reaching the water. The engineering team's analysis extended beyond the aircraft itself to what it revealed about American tactical doctrine. The Corsair was designed for a specific type of warfare, energy fighting, where speed and altitude advantage determined victory. American pilots were trained to use the Corsair's superior speed to control the engagement. They would dive from altitude, make a firing pass, and then use their excess speed to climb back to altitude before the enemy could respond. If a Zero tried to follow them up, the Corsair would simply outclimb it. If a Zero tried to run, the Corsair would chase it down. The only way a Zero could force a favorable engagement was if the Corsair pilot made a mistake and allowed himself to be drawn into a slow-speed turning fight. And by 1945, American pilots were too well-trained and too experienced to make such errors. Japanese combat reports from across the Pacific corroborated what the test flight had revealed. Pilots described Corsairs that attacked in coordinated pairs or four-plane divisions, using tactics that maximized their aircraft's strengths while avoiding situations that exposed their weaknesses. They described American formations that maintained altitude and speed discipline, that refused to be baited into disadvantageous engagements. They described combat outcomes where Japanese pilots, even skilled veterans, found themselves unable to bring their guns to bear because the Corsairs were simply too fast, too high, or too well coordinated. One particularly detailed report came from the aerial battles over Rabaul in late 1943 and early 1944, where Japanese Zero units had faced Corsair squadrons in sustained combat. The Japanese pilots noted that in low-altitude engagements, particularly below 3,000 meters, a well-flown Zero could sometimes achieve parity with a Corsair. The Zero's superior low speed, maneuverability gave it an advantage in turning fights, and if the Corsair pilot made the error of engaging on the Zero's terms, the outcome could favor the Japanese fighter. But these instances were becoming increasingly rare. American pilots had learned to exploit their aircraft's advantages, and they had the fuel, the aircraft numbers, and the replacement pilots to dictate when and where combat occurred. The kill ratios told the story with brutal mathematical precision. In the early months of Corsair deployment in 1943, when American pilots were still learning the aircraft's characteristics and optimal employment tactics, the combat results were relatively modest. But by 1944 and into 1945, the disparity had become catastrophic. Marine and Navy Corsair units were achieving kill ratios of 10 to 1, 11 to 1, sometimes higher. And these weren't inflated combat claims, though overclaiming was common on both sides, but results that were increasingly being confirmed by Japanese unit records showing devastating losses. Part of this disparity had nothing to do with the aircraft themselves and everything to do with pilot quality. By 1945, the experienced Japanese pilots who had trained for years before the war were nearly all dead. Their replacements were products of abbreviated training programs that could no longer afford to be thorough. A Japanese pilot might receive 50 hours of flight training, perhaps a dozen hours in type, before being sent to a frontline unit. An American pilot arriving at a Marine Corsair squadron in 1945 typically had over 300 hours of flight time, including extensive gunnery training, aerobatics, and formation flying. He would then receive additional training in theater before seeing combat. This pilot quality gap, combined with the Corsair's superior performance, created a situation where Japanese pilots were often outmatched before the first shot was fired. The Kasumigara engineers understood all of this. Their report on the captured Corsair would have included not just performance data, but operational context. They would have noted that the Americans were producing Corsairs at a rate of approximately 300 per month across 3 manufacturers, Vogt, Goodyear, and Brewster. They would have noted that by the end of 1945, over 12,000 Corsairs would have been built. They would have compared this to Japan's total fighter production, which was dropping precipitously as factories were destroyed by B-29 raids and as raw materials became impossible to obtain. The test pilot's brief flight in the captured Corsair had confirmed what many Japanese officers already knew but were reluctant to acknowledge publicly. The war in the air was utterly lost. Japan had no fighter in development that could match the Corsair's performance. The Mitsubishi A7 MEM Reppu, intended as the Zero's successor, was experiencing development problems and would never reach mass production. The Kawanishi N1KJ Shiden was an excellent fighter in capable hands, but it was complex to manufacture and plagued by engine reliability issues. The Nakajima Ki-84 Hayate was perhaps the best fighter Japan produced in the late war period, with performance approaching that of American fighters, but it was being built in numbers far too small to affect the strategic situation. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Even if Japan had somehow solved its fighter production problems, there remained the insurmountable obstacle of fuel. By 1945, the American submarine campaign had strangled Japan's oil imports. The synthetic fuel production facilities within Japan were being systematically bombed. Pilots were training on minimal fuel allotments. Operational units were husbanding fuel so carefully that aircraft often sat idle on airfields while American carrier planes struck targets with impunity. The captured Corsair at Kasumigara consumed fuel at a rate that would have been unconscionable for Japanese logistics. The R-2800 engine burned through fuel with an appetite that reflected American abundance. But that fuel gave the Corsair range and endurance that allowed it to escort bombers deep into Japanese-held territory, to maintain combat air patrols for extended periods, to dominate the airspace over contested islands. The psychological impact of the Corsair on Japanese pilots cannot be overstated. Imagine being a 19-year-old pilot with minimal training, climbing into a lightweight Zero with no armor, no self-sealing tanks, and limited ammunition, knowing that you're about to face pilots flying Corsairs, aircraft that are faster, more heavily armed, better protected, and flown by men with vastly more training and experience. Imagine knowing that if you're hit, you'll probably burn to death because your fuel tanks aren't sealed. Imagine knowing that even if you maneuver perfectly, the Corsair can simply dive away at speeds you can't match and return at its leisure to make another attack. This was the reality for Japanese pilots in the final year of the war. Some Japanese pilots developed tactics specifically for engaging Corsairs. They would try to force combat at low altitudes, where the Zero's maneuverability advantage was most pronounced. They would attempt to surprise Corsairs during vulnerable moments, landing approaches, takeoffs, while the American fighters were focused on ground attack missions. They would try to exploit any American pilot error, any moment of inattention. But these tactical adjustments were ultimately futile against the larger strategic reality. For every Corsair lost to a Zero, the Americans would replace it within days. For every American pilot killed, another well-trained replacement would arrive. For every Japanese pilot lost, which was happening at an accelerating rate, there was no adequate replacement. The engineers at Kasumigora documented all of this in their reports. They noted the Corsair's strengths: overwhelming engine power, robust construction, heavy armament, excellent high-speed handling, superior climb rate, ability to absorb battle damage. They noted its few weaknesses: reduced maneuverability at low speeds, complex maintenance requirements, visibility limitations during carrier approaches. They calculated performance envelopes, optimal combat altitudes, tactical vulnerabilities, and then they made recommendations for how Japanese pilots might exploit whatever marginal advantages remained available to them. But the subtext of these recommendations was clear to anyone reading them with understanding. There was no realistic tactical approach that would change the fundamental imbalance. The Corsair, flown by a competent pilot using proper energy-fighting tactics, was essentially invulnerable to a Zero, except through numerical superiority or extraordinary pilot skill. And by 1945, Japan had neither superior numbers nor an adequate supply of extraordinary pilots. The test flight at Kasumigara had simply provided empirical confirmation of what combat results had already demonstrated across thousands of engagements from the Solomons to the Philippines to Okinawa. There was a particular irony in the timing of these evaluations. The Corsair had entered combat in February of 1943, and its early performance had been mixed. American pilots needed time to learn how to exploit the aircraft's strengths, and there were teething problems with maintenance and reliability. But by the time Japan captured intact examples in early 1945, the Corsair had evolved into a mature weapons system operated by highly trained pilots using well-developed tactics. The Japanese were studying a perfected system at precisely the moment when their own air forces were disintegrating. The fate of the captured Corsairs at Kasumigora reflected the larger trajectory of Japan's war effort. After the test flights and engineering evaluations were complete, the aircraft sat in hangars as the war spiraled toward its conclusion. There was no fuel to spare for additional test flights. There were no resources available to attempt copying any of the Corsair's features for Japanese aircraft production. The engineers who had examined the aircraft were increasingly being reassigned to more pressing concerns, like preparing for the expected American invasion of the home islands. The technical reports they had compiled would gather dust in filing cabinets, read by officers who already knew the war was lost, but who lacked the authority or the courage to say so publicly. When American forces occupied Japan after the surrender in August of 1945, They found the Corsairs still at Kasumigora. The aircraft showed evidence of the Japanese repair work, fabric patches on the wings, salvaged components, handwritten Japanese inspection markings. American technical intelligence officers examined the aircraft and noted the Japanese modifications with professional interest. They documented the condition of the aircraft, photographed them from multiple angles, and eventually arranged for their disposition. One of the Corsairs was shipped back to the United States for study. The other was likely scrapped. The Japanese test pilot who had flown the Corsair, if he survived the war, would have carried memories of that flight for the rest of his life. He would remember the moment when the R-2800 engine roared to life, remember the acceleration that pressed him back in his seat, remember the climb rate that seemed impossible compared to anything he'd flown before. He would remember the speed, the power, the solid feel of the controls. And he would remember the sinking realization that had probably come over him during that flight, that Japan had been fighting an enemy whose industrial capacity and technological sophistication were simply in a different category altogether. The story of the captured Corsair at Kasumigora is ultimately a story about the nature of total war in the industrial age. It's a story about what happens when one nation's entire industrial base is mobilized for sustained conflict against an enemy that lacks the resources, the industrial capacity, or the strategic position to compete on equal terms. The Corsair wasn't just a better fighter than the Zero, though it certainly was that. It was a symbol of American industrial might, of a production system that could build thousands of complex aircraft while simultaneously building tens of thousands of trucks, ships, tanks, and artillery pieces. It was evidence of an educational system that could train enough skilled pilots to keep units at full strength despite combat losses. It was proof of a scientific and engineering establishment that could innovate continuously, producing new technologies and refining existing ones throughout the war. Japan had started the Pacific War with some of the finest naval aviators in the world, flying aircraft that were competitive with or superior to their opponents. The Zero in 1941 was genuinely an excellent fighter, and Japanese pilots were superbly trained. But Japan's industrial base was perhaps 5% the size of America's. Japan's oil supply depended entirely on imports that could be, and were, interdicted by submarines and air power. Japan's pilot training pipeline couldn't sustain the attrition rates of sustained combat, and Japan's aviation industry couldn't innovate and produce at the rates necessary to keep pace with American development. The test flight of the captured Corsair illuminated all of these disparities in a single half-hour sortie. Every aspect of the aircraft, from the massive engine to the self-sealing fuel tanks to the robust landing gear to the sophisticated propeller, told the same story about American advantages in resources, manufacturing, and design philosophy. The Japanese engineers who examined it understood this. The test pilot who flew it understood this. And increasingly, as 1945 progressed, Japanese military leadership understood it too, even if political considerations prevented them from acting on that understanding until atomic weapons and Soviet entry into the war forced their hand. For the American pilot who had ditched his Corsair off Yokosuka in February of 1945, the loss of his aircraft was a temporary setback. He was likely recovered by American forces within days, returned to his carrier, and assigned a replacement aircraft. He probably flew combat missions for the remainder of the war, possibly survived, possibly returned home to a post-war life where he rarely thought about the aircraft he'd lost off the Japanese coast. He would have had no idea that his Corsair Bureau number 82410 had been salvaged by the Japanese, repaired at Kasumigora, and flown by an enemy test pilot who learned from that flight just how comprehensively Japan had lost the technological and industrial arms race. The broader context of captured aircraft evaluation is worth considering. Both sides in World War II devoted significant resources to studying enemy equipment. The Americans had operated captured Zeros, studying their strengths and weaknesses to develop tactics that would neutralize Japanese advantages. The British had examined captured German fighters, learning from their engineering while identifying their vulnerabilities. The Germans had flown captured Soviet aircraft, sometimes incorporating features into their own designs. This was standard practice in modern warfare. You studied your enemy's equipment to find ways to defeat it. But what made the Japanese evaluation of the Corsair particularly poignant was its timing and its futility. By early 1945, there was nothing Japan could do with the intelligence gained from studying the Corsair. There was no way to significantly improve Japanese fighter performance with the resources available. There was no tactical innovation that would overcome the fundamental performance disparities. The information was accurate, the analysis was competent, but it was strategically useless because Japan no longer had the capacity to act on it meaningfully. The technical specifications of the Corsair tell part of the story, but they don't fully capture the lived experience of combat. Japanese pilots who survived encounters with Corsairs described the psychological impact of facing an enemy who held every advantage. They described the frustration of watching Corsairs dive away whenever a Japanese fighter achieved a favorable position. They described the terror of Corsair gunnery. 6 .50 caliber machine guns firing in unison could destroy a Zero with a 1-second burst. They described the hopelessness of knowing that even if you shot down one Corsair, 3 more would be in the air the next day while your own unit scrounged for replacement aircraft and fuel. By the time of the Okinawa campaign in the spring of 1945, Japanese air power had been reduced to essentially one tactic: kamikaze attacks. The logic was grimly practical. If Japanese pilots were going to die anyway, and if their aircraft were increasingly unable to compete in air-to-air combat, then using them as guided missiles against American ships at least inflicted damage commensurate with the loss. Conventional fighter operations against aircraft like the Corsair had become so one-sided that suicide attacks represented a more efficient use of diminishing resources. The Corsair continued in service long after the war ended. It flew combat missions in Korea, where Marine pilots achieved victories against North Korean aircraft, and where at least one Corsair pilot shot down a MiG-15 jet fighter in what must have been one of the most improbable aerial victories in history. The French flew Corsairs in Indochina in the 1950s. Some examples remained in service with smaller air forces into the 1960s. The last combat mission flown by a Corsair was in 1969 during the so-called Soccer War between Honduras and El Salvador, 24 years after the Japanese test pilot had flown the captured example at Kasumigara. For aviation historians and enthusiasts, the story of the captured Corsair represents a fascinating footnote in the larger narrative of the Pacific War. It provides a glimpse into Japanese technical intelligence operations, demonstrates the thoroughness of their engineering analysis, and reveals the stark recognition by Japanese experts of the technological gap they faced. The surviving documentation, though fragmentary, shows that Japanese engineers were under no illusions about the capabilities of American aircraft or the implications for Japan's strategic position. The human element of this story deserves consideration as well. The test pilot who flew the captured Corsair was performing his duty under extraordinarily difficult circumstances. He knew the war was lost. He knew that any intelligence he gathered would likely make no difference to the final outcome. But he flew the aircraft anyway, compiled his report anyway, provided his professional assessment anyway. This speaks to a kind of professional dedication that transcended the larger strategic hopelessness of Japan's situation. The engineers who examined the Corsair, who documented its features, who analyzed its capabilities, they too were doing their jobs with competence and thoroughness even as their world collapsed around them. There's a broader lesson here about the nature of industrial warfare and technological competition. The Pacific War wasn't decided primarily by individual heroism or tactical brilliance, though both
were present on both sides. It was decided by industrial capacity, resource availability, technological sophistication, and the ability to sustain military operations over time. The Corsair was a superior fighter to the Zero, but it wasn't a wonder weapon. It was simply a very good aircraft produced in large numbers, flown by well-trained pilots, maintained by skilled mechanics, and supported by a logistics system that could keep it fueled, armed, and operational. Japan's defeat in the air war, symbolized perfectly by that test flight at Kasumigora, was the result of cumulative disadvantages across every dimension of military aviation. Fewer aircraft, less fuel, shorter pilot training, reduced industrial capacity, limited access to strategic materials, smaller pools of skilled workers, vulnerability to strategic bombing, dependence on fragile supply lines. The Corsair represented what was possible when those disadvantages were reversed, when every factor favored the side building and operating the aircraft. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.